Alright, so right now we're adding 20 drops of COCl2 solution to each test tube before we start. And the solution is at 0.1 moles.
What you'll do, I can cut those what you'll do is just on a little bowl,
Here, down some and then. Oh, this is the control. So.
Alright.
Come over here really quick and take their calcium.
So much deeper.
And so now we add 1 milliliter of concentrated hydrochloric acid.
Where is it?
3.
Yeah, hydrochloric acid.
We add 1 milliliter of concentrated hydrochloric acid to each test tube. B, C, and D. So don't do A.
Wait, first milliliter of test tube.
Before we do that, we add 1 milliliter of distilled water to test tube A. And then we record the color of the test tube.
No, this is. I think that's just water, because this is for the hydrochloric acid.
How do you measure for 1 milliliter?
Pretty sure. Well, this can hold. Right there is 1 milliliter.
Is there anything in there?
But I don't know what this is. I think that's
That's
water.
for like the water bath thing. Is there anything in here?
No, but I don't know if that's for something else. It's just distilled water anyway.
Okay, 1 milliliter of water.
They're not even like, plastic. So, if you don't have one, they just excuse me.
So add 1 milliliter of concentrated, 1 milliliter of distilled water to test tube A. And then we add 1 milliliter of concentrated.
So this is the characteristic color.
So 1 milliliter.
Alright, that's the color. Show them the ion.
That's the color, and here's the ion. Right there.
So this test tube aside as a control solution. Alright, so A is our control. Slowly and carefully add 1 milliliter of concentrated HCl to each test tube B, C, and D.
Dispense concentrated hydrochloric acid in a fume hood or well-ventilated lab only. Scotch tape cap. Or no, that's wax paper or something. So he's getting 1 milliliter of the acid.
Oh,
It's just like.
What?
just gotta whip it. That's strong. It's very, very strong.
It is 12 moles, I
If you're
think.
low on any of your chemicals,
1
let me
milliliter.
Water.
Oh, and by the way, I would turn on your hot plates now so your hot water bath can start heating up.
Look.
That way you don't have to wait. Right there.
And that's the color of it after adding the hydrochloric acid. It goes from, when added,
This to this.
it goes from that to that. Pretty cool. Goes from pink to violet.
We need more hydrochloric acid.
Still Alright, let me turn on the hot plate. So then while we're adding the acid, we're gonna turn on the hot plate. So as to get it ready when we're on the step for the water. We ran out of hydrochloric acid and we're adding more right now.
You can use the pipette and pipe it in and out. But
That's what we're doing.
But it's doper this way. See it like fuming? It's kind of sick. Be very careful, Gavin. Don't kill anyone.
I'm gonna get this for so we can see the reaction.
Alright.
Oh, that was cool.
That's weird. It should be the same color because we put the same stuff in. Alright.
Maybe it's different because of different test tubes. I don't know.
Maybe this one was a little less full. Let's see if yeah. Alright. So this one I accidentally put a little less than this one.
So that's what the color should actually be like. Maybe add a little bit more to the D because it's kind of fluctuating a little bit. And then add to the D.
Add a little bit of bubbles in there.
Alright. Using a glass stirring rod to mix each solution. Record the color of the solutions and the table record. So yeah. So now he's gonna stir it so that the solutions are mixed. That's the next one.
And once again, before you start step 5, check with me or Madeline just to make sure you're
What watch is that? And right now he's stirring it.
set test tube B aside.
So you just finished step 4.
Alright.
This is the colors is the characteristic color of the COCl42 complex ion.
Set test tube B aside as a reference solution. Alright, so
So
A
put it at the end
and
of
B.
the thing.
We'll just remember. A and B. Okay, we'll separate them.
Alright, 4. Add distilled water dropwise to each test tube C and D until the solutions reach an intermediate or transition color midway between that observed in steps 4 and 5. Record the amount of water added and the transition color in the data table. Effect of concentration.
You can turn it up high and then turn it down.
Test tube C and D. Alright. I'm gonna start recording this. We can pause the video while we do it.
Now we're going to add distilled water to find how much water it takes to reach transition color for the test tubes.
Alright, I'm gonna do it just drop by drop.
Alright,
But I'm gonna do it in amounts of 1
it
milliliter.
did say drop by.
Okay, so we're trying to get it to be in between these two colors.
Yes. Alright, and now he is stirring it.
Thank you. All right, would you say that's a pretty good transition color between the two?
Yeah. Alright, how many drops was that?
That was 1 milliliter. Almost exactly. Is that for both of them?
Do we do it?
You can pause the video.
C and D. We're supposed to do C and D. And it said drop wise.
Test tube C. Oh, okay.
How many drops would you say are in a milliliter?
Well, wait, where'd the water? Oh, here. Well, let's see. We can test that. See.
Yeah.
12, 3, 16, 17, 18, 19, 20, 21, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So about 33.
How many?
33.
Alright, so it took 33 drops to reach transition color between test tubes A and B. We are trying to get transition color for test tube D.
I think color is done. Yeah, it's at 120. So, yeah.
I think we got it.
Is that close enough, or should we add more?
That's good.
Because the more water, the closer it is to this.
Yeah, I think we got it.
Let's see.
Alright, so about a milliliter. And
That's more of a salmon. That's okay. We can do the Lachapnier explanation later. Yeah,
and so now we are recording how much water it took to reach transition color. So for test tube C, we got 1 milliliter / 33 drops.
Well, it's the same for both.
Yeah.
Because it's the same solution. Okay, so transition color. They can fill out the data table themselves.
Yeah.
So transition color, what would you say that is? Like rose? Or
Salmon. Like a light salmon.
slightly. So this one's more like a salmon.
it's kind of quiet compared to me. I'd say.
This one's closer to like just pink. This one's not salmon.
White. Or salmon white.
It's not salmon. Alright, that's good. Effective H2O addition. Alright.
We are adding water to the two test tubes until there is
No visible change.
I might have just stepped on it. Yeah, is that what it's supposed to look like? Oh, there's a little blue at the bottom.
That's no visible change. Wait, until there's visible change or
Until there's no visible change. See.
Let's just say not the
So the color solution is stable and no water change. Alright. So It's just. Yeah, that's not changing anymore. Alright, let's do it with this one.
Why is our water still at 100 degrees? What the fuck? Here, just stick your hand in there.
Now we're doing it to test tube D.
Yeah.
So one thing to remember is whether it's X or endo, right?
Yep. Hasn't changed at all.
Alright.
So, effective H2O addition.
Yeah, at the bottom.
So before they're supposed to fill this out themselves.
So now fill out your table for. We are now adding solid pieces of calcium chloride to test tube D.
And make sure to specify that we reset it.
We reset test tube D because we accidentally did step 5 for it too. When we were only supposed to do it for C. Now he's staring in. And once it's done, record the color of the solution in the data table. I'm smashing it.
But yeah, we want to give it more surface area so it can react, right?
Yeah.
Yeah, it's 80. Oh, wait, does it have it? Dark. I'm just gonna say dark pink. Yeah, stick it in the ice. What color was it supposed to turn? Well, it got darker, so I'm assuming it was supposed to become like blue or something.
Yeah, so I'm like,
So, I think it's like a good darker. So, based off what you're seeing with this, part of it is the reaction
no change.
You talked to it.
Which side is pink?
That is the question.
That's
Oh, too close. And that's what it looks like after the solid calcium chloride has dissipated. Alright. And now record the color for test tube D in your data. So now we are adding 1 milliliter of silver nitrate to test tube D.
I said I'm pretty aqueous. Ah ha ha ha. Ah ha ha ha.
Okay, now we just need to wipe down the counter.
One of the best jokes I've ever made.
Yes, that was such a good science joke.
Thank you.
Give them points, and then in the comments.
Cloudy.
Alright, that was 1 milliliter of silver nitrate.
So now it doesn't say mix. Just record the color and appearance of the solution in the data table.
Well,
So
we'll mix
then
it to get an
cloudy.
accurate reading.
Hi, Bryce, we heading out?
Yes.
It would have come. Honestly, I think I'm just gonna keep the goggles and the apron. You know? Yes, they say this virus,
Alright.
man. You never know when it's gonna sneak up on you.
And so now record the color and appearance in your data table. Key. When recording your observation, there is a precipitant at the bottom.
It's solid.
I know.
Dude, this is a squirt gun, man.
And test tube D into a hot water bath at. Oh, you just cracked open the bottom.
Did that? Oh my gosh, that thing is so. Well,
So we just put in test tube C into a hot bath at 80 to 85 Celsius. And we leave it in for 2 to 3 minutes. Thank you. As you can see, the color is darkening due to the heat. Now we take it out, and then you can see that the color has darkened when it is heated. And so now we have an ice bath right here.
Okay, I just want to make sure I do it right.
Alright.
See, test tube. Oops. Alright, cool it briefly. We don't want to have another crack.
Yeah. And so now we put it into the ice bath to see its reaction.
It's too hot.
After we pull it down a little bit so it doesn't crack. Good. Right. And there it goes. Yeah. You can already see it has begun brightening in color.
There's 2 minutes.
There we go. Now,
Here, let's hold it up
yeah.
behind the white so they can see the color.
So you can see that the solution has brightened in color after being cooled down. Now you can fill in your observations on the data table. And now it is in an ice bath about to come out.
It's
from
been in
cooling.
for about 2 minutes.
And you can see that the color has brightened and gone back to its original color.